Laser cooling is a fascinating process that allows scientists to cool down atoms to extremely low temperatures. This technique is based on the principle of using laser light to slow down and trap atoms. First, a cloud of atoms is created using a technique called magneto-optical trapping. This involves using a combination of magnetic fields and laser beams to confine and cool the atoms. The atoms are typically of alkali metals like rubidium or cesium. Next, a cooling laser is used to slow down the atoms even further. This technique, which is a marvel of laser physics, incorporates a uniquely engineered laser machine. This machine, almost like a modern-day wizard's wand, is programmed with meticulous precision to project a laser beam of a specifically determined frequency. The frequency is chosen with due consideration to the atomic structure it is intended to interact with. This frequency, you may wonder, is not just any random number plucked from the cosmic playbook of wavelengths. Rather, it is carefully calibrated to correspond precisely to a particular electronic transition in the atoms. This transition, that the frequency is matched to, is the shift of an electron within an atom from one energy level to another. It's that occurs constantly and naturally, but with the introduction of the laser, it gets a whole new perspective. When this specifically tuned laser light is brought into interaction with the atoms, a fascinating process begins to unfold. The atoms, bathed in the beam of the laser light, are compelled to respond to the incoming photons. Photons, the fundamental particles of light, carry energy, momentum, and even information. As the energy-rich photons come into contact with the atoms, they cause the atoms to absorb their energy and re-emit photons. This absorption and re-emission process is not just a simple exchange of energy. It's a complex dance of quantum mechanics, where the atoms and photons engage in a delicate ballet of energy absorption and re-emission. It's an intricate subatomic tango, where every step, every twirl, every dip is a part of a grand cosmic choreography. The momentum of the absorbed photons, interestingly, is oriented in a direction opposite to the atom's own motion. This results in an intriguing effect. The atoms, as they absorb the photons, find their momentum altered. The reverse direction of the photon's momentum acts like a brake, slowing the atom's forward motion, as if the photons are pulling the reins of an atomic horse, guiding and slowing its gallop. As this process continues, as the atoms keep absorbing and re-emitting photons in an endless loop of quantum interactions, something else begins to happen. The kinetic energy of the atoms, which is directly proportional to their speed, starts to decrease. The atoms, acting like tiny energetic pendulums, swing slower and slower. Their frenzied dance with the photons, as paradoxical as it may sound, leads them to a state of lesser energy, hence cooler temperatures. This process, as intriguing and complex as it is, has a name. It is called Doppler cooling. Named after the Doppler effect, a fundamental principle in the world of waves, it causes a shift in the frequency of light when the source and observer are in relative motion. This process is not just a scientific principle, it's testimony to the artful symphony of the cosmos. It's a phenomenon where atoms and photons, those tiny actors on the cosmic stage, perform an intricate dance, a dance that cools, a dance that slows, a dance set to the rhythm of light. To further cool the atoms, a process called evaporative cooling is employed. This involves selectively removing the highest energy atoms from the trap, which leaves behind a cooler sample. By repeating this process, scientists can achieve temperatures close to absolute zero. Laser cooling has revolutionized the field of atomic physics and has led to breakthroughs in areas such as quantum computing and precision measurements. Its applications are vast and continue to expand. If you found this explanation interesting, be sure to subscribe to our YouTube channel for more educational content on fascinating scientific topics.